For the first one, I'm assuming everyone did good on the slope field. Yes. So you had to find the actual slope at each point. So that took just a bit. 2x minus y. Okay, so it was a slope of, this was like a slope of 1. This was, I think, a little bit steeper at like 2. This was a slope, yeah. This one, I'm just copying my, I should probably copy the answers instead of mine, but I think I did. This one was like 1, but this one was super steep at like 3, I think. Yeah. All right, so 1 point for putting the places where the slope was 0, and 1 point where x equals 1. What does that even mean? You get 2 points for the slope field. Two. Maybe so. That's. Oh, yeah, there's nothing on there. It shouldn't be. Yeah. You only had to put it where there was points. I would only put them where the points are, just in case. I would be scared that I did it wrong and then they might take off. You know what I'm saying? But I don't know. I don't know. Okay, moving along. Part B asked for the second derivative in terms of x and y, and then to determine the concavity. This was a thought. Okay, second derivative. As we get further in the years, it seems that implicit differentiation is tested heavier and heavier. All right, so if the first derivative was 2x minus y, then the second derivative, remember, we're taking it with respect to x. So here it's 2 minus dy dx. No, you don't get a point unless you've gone back and plugged it in. Okay, so it's.
So what if you wrote it like you just put dy dx equals 2x minus y, like that equals. I have 2 minus 1 dy dx.
Yes, but then you have to show. This is the point they're getting at, is that you know that that happens. That's a point. Whether you put it like that, I simplified it a little bit and did 2 minus 2x plus y. Either one of those would get you a point. Okay. So then it asked you about concavity, but concavity in quadrant 2. So here's what I thought. This was my reasoning through here. I said, okay, in quadrant, where is quadrant 2? That's negative positive. And so I said, okay, well, in quadrant 2, x is always negative, right? Because this is Q2. And y is always positive. Agree or disagree? Okay, so I want to know what the sign of the second derivative is doing there. Well, if I've got 2 minus 2x plus y, and x is always negative, well, if x is always negative and I'm subtracting here, then I'm doing 2 minus negative 2 times what, right? So this is going to stay positive. And if y is always positive, so it's always concave up in quadrant 2. So I would think you get 1 point for concave up with reason, and I would say their solution says I'm always worried, so I write a novel every time I'm not sure what to put. So I mean, I went through in quadrant 2, x is always negative, y is always positive. I did greater than and less than, and then I wrote out. I did just like this, and I said that would make that would force negative or force positive. Always positive. And then, so then I came down and I said, therefore, Concave up because the second derivative is always positive in quadrant 2. Yeah. So 1 point for each of those for the answer and the reasoning. But you have to show it for all values in quadrant 2. You see what I'm saying? Not just 1 point. Like, read me your reasoning. I think you have to reference the values in quadrant 2 to get the reasoning on that one. Because x is always negative and y is always positive in quadrant 2, it forces the second derivative to always be positive, which would indicate concave up or something along those lines. Okay, let's look at part C. I thought part C was part D was the hard one. C and D were pretty difficult here. All right, so part C was worth 2 points. It asked you to let f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Oh, this one wasn't hard. It doesn't. It's neither. And here's why. So if you think about it, it says, does f have a relative maximum, minimum, or neither at x equals 2? So I literally wrote here, I said, okay, if dy, and this was my reasoning again. Remember, I haven't looked at these until y'all sit down because I want to feel like, all right, there's my derivative, and that tells me my slope, right? But what happens with the derivative when you have a maximum or a minimum? It's 0. So my question is, does 2x minus y equal 0 when I have the point 2, 3? Because that's what they gave me. So if I plug in 2 and 3, does it equal 0? So the derivative at 2, 3 is 2 times 2 minus 3, which is 1. So therefore, no, it does not have a max or min because the derivative is not 0 at that point. I think you have to say, you have to show that the derivative does not equal 0. Somewhere on here, you need to show that you know that it has to equal 0. Or in your reasoning that because the slope is not 0, there's no maximum or minimum. So you got 1 point for plugging in, and you got 1 point for the reasoning.
So,
Right, yes, yes. Nope, nope. 1 point if you considered the derivative at 2, 3.
okay, so what I did was I said 2x minus y equals 3, and I got 1.
Why'd you set it to 3?
Well, I just plugged in x, or f of x, x is the x, and the y is 3. I just plugged it back into and I got 1.
Yes, so you get a point for that.
And then okay.
So maybe you didn't get a point for the reasoning, but you got a point for plugging in and considering.
So what about, I put neither.
Did you justify your neither? Did you say neither because the slope is not 0 at this point, or because the derivative is not 0 at this? So I'd say 1 out of the 2. D was the hard one, and I don't want to get bogged down on D. 3 points. M is 2 and B is negative 2. I did not get my answer point on this one. Okay, I ran out of room and I just went on. Okay, so let's read through it. Find the values of the constant M and B for which y equals mx plus b is a solution to the differential equation. So, first of all, what does that mean, being a solution to the differential equation? If I plug it in, right, it works. Okay, so here was my thought process. So I said, okay, well, I'm going to find the derivative of this equation. Derivative of this equation is just going to be m. Do you agree? Okay, but then how did you go about using it to solve? Okay, here was what. It's not a point yet, but it's fixing to be a point. Because here's what I know. I know dy dx, right? And I know dy dx equals 2x minus y. If this is a solution, then the derivative of this one should equal this one. Okay, so I should have m equals this, right? And I know that y is mx plus b. It's a whole bunch of subbing. That's exactly what it is. So now m equals 2x minus mx plus b. There's your first point right there. Actually, no, I lied. This is one point right here. If somewhere on there you did that, you got a point. You get a point, yes. That's 1 point. If you found the derivative of the solution equation they gave you, you get a point. If you then here's where they lost me on their solutions. So now they have, oh no, wait. If you got this, that's point number 2. 2x minus y equals m is point number 2. I got that. I got this, and that's what they got. And then that's where we stopped getting the same thing. You need to find m and b. So here's what they did, and I'm just going to show you what they did. They did 2 minus m times x minus m plus b equals 0. Okay, so let's see. They made everything equal 0. So you got 2x minus mx minus b minus m. They factored an x out of these two.
How did you do it?
I stopped here to go on to the next one. I said, screw that 1 point on that answer. I'm going on. Because I had 2 of my 3 points, and I was like, you know what? Nobody ever cried over 1 point. It's okay. I wanted to make sure I had time to do the rest of them, and then I forgot to come back, to be honest. Okay, so let's see. X times 2 minus m minus b plus m. So we're trying to find out what the values of what m and b are. I'm not gonna lie, I don't see where they, so here's, and y'all can see if it makes sense to you. They said, okay, 2 minus m equals 0. Okay, wait, let me think, because this looks just like, and then they said b equals negative m, so b equals negative 2. There's a point if you got that answer. I don't know how they got from this to this. I'll have to sit down with that. That's a bit of a stretch, I think. It's coming from somewhere. I'm not real sure.
Well, they're saying we should know how to do it.
I'm gonna look at that. That's got something to do with the previous part of the problem. I just gotta have time to sit down and think about it. All right, number 5. Number 5, I felt like I wrote an essay every time.
Yeah, me too.
So ones like this, they really want everything in words when it says justify. So make sure you're doing that. I did a sign chart for A and B, but then you have to interpret that sign chart. So
Okay,
yeah.
so I did a sign, so I skipped A, then I did a sign chart for B, and I had to do separate things for A.
To answer C.
No,
Well,
like, when I had to
your
write
sign
it,
chart, you'd have to write it out, but your sign chart is not justification for them anymore. So
like, I put it,
that is just for you to find those values. They used to count that as justification.
Say the same thing in work.
You are. And they used to accept that. It used to be valid justification, a sign chart, but for some reason they want it in words now. I don't know. All right, so it asks us first to find, first of all, I messed up again and did not read the full question, and I couldn't figure out once I got to D how to answer the last part of it. And I went, God, this is ridiculous. This is the second D that I'm not. And then I went back and read it, and they gave it to us. Make sure you read the whole question before you start.
I actually did, I went back and looked at it. I wasn't sure if I did it correctly.
Yeah. All right, so part A, all coordinates for which f has a relative maximum, give a reason for your answer. So since this is the derivative, it'll tell us what the function is doing. So where is the derivative 0? And since this is the graph, where's it crossing? It's crossing at -2, at 1, and at 4. So those are my potential maxes or mins. So here the function is positive, negative, positive, increasing, decreasing, increasing. Negative. Yes, I'm looking at the wrong one. Yes, I'm looking at the wrong sign chart. Gosh. Okay. Yes. So I said relative max at x equals -2 because f prime changes from positive to negative at this point.
Yeah, well, what?
Wait, what?
Did you say negative to positive?
No, I wrote the minimum instead of maximum. I literally, on my graph, I have negative max.
Dylan.
Bro, what? Nah, I should get one. I would, nah, that's so dumb. I had.
1 point for x equals -2. Not at 1 because the sign doesn't change at 1.
It's just, like, when I drew it out, it's like, I drew out, so I did, like, that, and I was like,
So remember what happens at maxes and mins. This is what I've been trying to tell Algebra 2. If it doesn't change direction, so I'm decreasing, decreasing, decreasing. If I never stop and start increasing, it's not a relative maximum. You see what I'm saying? So it never. So we call them turning points sometimes. Is what I've been teaching them. If it doesn't turn, it's not a maximum.
what would I get wrong?
So if you identified x equals -2, you get 1 point.
What if I identified it on the graph? What did put in my answer?
Dylan, I don't know. Use your discretion. Yeah. Yes. Yes. But you have to somewhere say positive to negative at this point.
That's 2 points?
Yeah. 2 points altogether. 1 for each. There, the what changes direction? Okay, so here's the slope doesn't really change direction. The slope changes sign. And here's one thing too to note. When they're asking you for reasoning, and I make this mistake a lot. Make sure you use what's given as your reasoning. Like, don't say when we get to concavity, don't say because the second derivative, blah, or because the function, if I'm looking at max and mins, because the function, don't do that. Use what they gave you. So they gave you the first derivative. So because the first derivative changes from, yeah.
So because from negative 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 2.
Correct. Because this is the derivative graph.
So this, correct me if I'm wrong, the slope is decreasing on this.
Okay, but the slope of the derivative would give you the second derivative. Because remember, derivatives are slopes. So if I look at the slope of this one, I'm talking about a second derivative situation. Does that make sense?
So the derivative of the parent is above because because it's
Right. So increasing, decreasing, decreasing. Yeah. All right, part B. What? On B? No, because you shouldn't be looking at slope on it.
Because the derivative graph is showing you what the slope was on the.
But use the first derivative. Use what you know, what you're given to justify your
So what
answer.
should I say? It has to be x-axis.
So you should say because the derivative, or because f prime changes from positive to negative.
It's less positive than one x.
Oh my gosh. Okay, part B. What open intervals contained in -3, 4? So I'm only looking from, okay, that's the whole thing. Is the graph concave down and decreasing? So this is where you really have to look at them together. -2 to -1 and 1 to 3. Let me make sure that's right. Yeah, -2 to -1 and 1 to 3. All right, second derivative and f. Here's where your reasoning is going to mess you up here because it messed me up here. All right, so the first thing, now I'm looking for where slope changes because I'm looking for the derivative of what's given to find the second derivative. So those are my maxes and mins. So I've got -1, which is going to happen about right here, and I'm doing this intentionally so that we see where these are divided out. All right, -1, 1, and no, I gotta have 3 on there. 3 points. No. And I did this so that I could see it as compared to, because it's asking me for concave down and decreasing. Okay. All right, so this was -1. What was this? 1? No, there's 1. That's just the dividing. Okay. Put it in a different color. -1, 1. All right, so remember I'm looking at the sign of the slopes here. So I start with a negative slope because I'm going down, right? Then I go up, then I go down, then I go up, and then past 3. Is that right? What did I mess up?
1 to 3.
Oh, this is still positive. This is negative. There you go. So this is concave down. These are all concave up here, concave down, concave up.
How do you say this one?
Okay, so this one, we know that it's -2. I did it in interval notation. Okay, so you'd have to reference, yes, that's what so you'd have to say that the graph is both concave down and decreasing because the first derivative is negative and the first derivative is decreasing on these intervals. Don't reference the second derivative here because that's not what's given as justification. You see what I'm saying? They gave you the first derivative graph, and that's what you need to use to back it up. So they're looking to make sure you know. I did both. So yes, and I think that's fine as long as you do both. Yes, absolutely.
Both concave down and decreasing. Why can't I say on these points because from these points the slopes are negative? When I can draw it out, and I did. Their slopes are negative. Like I drew out and again where from negative 2 to 1. -2, -1 is a negative.
No, remember, they're not going to look up at the graph, I don't think. I think they're only going to grade what's in the space to grade. You see what I'm saying? So you need to repeat it if you put something up here. Yes. Let me read you their reasoning. The graph of f is concave down and decreasing on the intervals -2 to -1 and 1 to 3 because f prime is decreasing and negative on these intervals.
So what is prime? That's not slope.
F prime is the graph that was given to us.
But when you have f and when you take the derivative.
Right, yes. Yes, so if you said the slope was negative on that interval, say the slope of f prime is negative. Make sure you're specific in what you say. I think because they're just so picky about making sure that you understand. All right, A was worth 2, B was worth 2. Part C, if you did part B correctly, then part C was a cinch because it asked you for the x-coordinates of all inflection points for the graph of f. And so those, of course, are -1, 1, and 3. You got 1 point for listing those. The reasoning is because the derivative graph changes direction. Exactly, changes direction.
I said they were the horizontal
I said, yeah, horizontal axis.
I think you need to say it changes direction. Right, right. It goes from increasing to decreasing or from decreasing to increasing. 2 points for that one too. Then part D. Part D was a test of the fundamental theorem. Given that f of 1 equals 3, write an expression for f of x that involves an integral and then use it to find f of 4 and f of -2. So, for the integral, because I'm going, let's see, I did f of x. Remember, we've got the graph of the derivative, right? So, the first part is 3, and then from there, I'm going to start at 1 and go to x of the derivative, but remember these change of variables here that way, the way the fundamental theorem. All right, so from -3 up to 1, I know that it's 3 because they're telling me that. They're telling me that's the amount, okay? Because remember, that is the integral, right? Because I've got the graph of the derivative. So I need to add that, and then I have to pick up from 1 to whatever else it is. So I can't use x in here again. So it's f prime of t dt. Okay, so this is, and that is straight fundamental theorem is all that is. Okay, and then they said, so you got a point for that. Did anybody get that? F of 4 then is just a plug-in situation. It's from 1 to 4 of f prime of t dt. And we know by the fundamental theorem, if you look up at the beginning, this is where I did not read the last part. I was trying to, it's actually -12, right? Because it's below the axis. They give you the area, but then you have to interpret that, oh, but you know what? They gave me area and not integral. So this is actually 3 minus 12, which is 9. But that was given to you in the beginning. And if you have a whole sentence of information like that that you haven't used.
I haven't used it, but I just got the wrong.
They gave you that in the beginning. It said the area, yeah. Oh. Okay, and then f of -2, yeah, I'm sorry, too, is the same way, 3 plus the integral, but here's where things get a little bit sticky. You're exactly right, Ren. You have to flip it because my small value is not up top, so this becomes 3 minus the integral from -2 to 1 of the derivative. That's right. And so since it's still negative because I'm still below the x-axis, this becomes 3 minus. This integral is, what did it say? -9. So this would be 12. So you got 3 points there. One for the integrand. Okay. All right, we got 5 minutes to make it through the last one. I agree. Okay, part A, so consider the curve. I've got this curve and I've got the derivative that they've already found for me, so that's nice. Write an equation for the line tangent to the point at -1, 1. Tangent means there's my point. I need a slope, so I'm going to use the dy dx equation, which is y over 3y squared minus x. Plug in and you should get 1/4. There's a point for 1/4. Then you've got your point, y minus 1 point slope. That's exactly right. All day long, there's your second point. 2 points. Part B asks you to find all the coordinates on the curve at which the line tangent to the curve at that point is vertical. So what does that mean about the slope to have a vertical tan line? That's a horizontal tan line. Okay, so here's where I started with mine. I went, and y'all think I'm crazy, but I literally write these on my paper. Vertical tan equals undefined slope. How am I going to make, if I've got the equation of the derivative, which is the equation for the slope at that point, how do I find where that is undefined? That's denominator equal to 0. If I want to know where it's 0, I set the numerator. If I want to know where denominator, set denominator. So when does that happen? What is that?
Just like you did that 1/4.
But it's got to be at that specific value.
No, I'm like there.
Nah. Okay, so here, that means if I add x to both sides, x is 3y squared, right? So I have to go back to that original equation of y cubed minus xy equals 2, and I have to plug this in for the x value.
Wait, what?
All right, because this is the slope. So I know that when x equals 3y squared, the slope is undefined, right? We all agree with that. By the way, this is 1 point here. If you set the denominator to 0. All right, this is the original equation, yes? Okay, so I want to know when in my original equation does x equals 3y squared? So I'm going to take that original equation and say, okay, well, y cubed minus 3y squared times y equals 2. Can you now solve that for y? Yes. If you got to this point where you had an equation with just one variable, they gave you another point. Minus 3y cubed equals 2. These are like terms now, so negative 2y cubed equals 2, so y is, of course, negative 1. You do have to plug that back into the equation to find x. And when you do that, for the sake of time, I won't do that, but make sure you go back and do that. You get x equals 3. So there's your last point or the coordinate. So 1 point for setting the denominator to 0, 1 point for writing the equation in just one variable, and 1 point for the coordinates. Last one was the doozy one. Evaluate the second. 1 over 32.
What if I just left it as? What if I left it as?
There's 4 points for that last question.
You said 1 over 32.
Yeah. All right, let me run through this just quickly. If I do the second derivative, this is, the second derivative, this is nothing more than a quotient rule problem, right? So it's derivative of the top, dy dx times the bottom minus the top times the derivative of the bottom, 6y dy dx minus 1.
I just forgot about the bottom.
Implicit differentiation, get you 2 points there. Okay, so being able to derive implicitly with your dy dx gets you 2 points. At this point, I said, what is dy dx at that specific point, which they said -1, 1. This? No. The red, yes. The red is 1 point. I'm going to finish real quick. Dy dx at that point is 1/4 if you plug it in. That just made my life a little bit easier because, I'm sorry, because, okay, you want to put it in your black folder? Yes. Because I just have to plug that in there, right? For every dy dx, I can just plug in 1/4. All right, then for every, what? It March the 5th was. They just give it to it once a month. So I plug in my x and my y values here, right? Simplify it down. It's a whole lot. If you sub this in for dy dx somewhere, that's another point. So here's 1 point. 1 point for subbing in dy dx into your implicit differentiation. I would give you a point. Then 1 point for the answer. So 1/32 was the answer once you plug it in. So if you implicit differentiation, 2 points. Subbing 2 points for implicitly differentiate. So if you were able to get the pink, that's 2 points. Plug in the 1/4, that's a point.
I only plugged in at one.
Are you joking? And then the answer is your 4 points. 4 points. When you plug in 1/4 here, and they asked you at -1, 1, so you put 1 and -1 in for every x and y. All right, how'd y'all do?
I got one. I got one more than the last time.